Good morning, boys and the girl. I think the girl has joined. So we were discussing basically chapter number 7, structural organization in animals. When you say structure, it means size and shape. Size of the cell, shape of the cell. And all of us know that cells of similar kind will join together and form a tissue. So because of the cell size, cell shape, automatically tissues also will be decided. What shape they should be, what size they should be, what are the chemicals that are present in the cell, in the cytoplasm, and in what way those chemicals help the tissue or the cell to perform the functions. So, structure almost decides the function, and what function is to be performed, where it is to be performed, because of cell differentiation. Yesterday I told you cell differentiation, that particular tissue goes and occupies that position. Yesterday I gave the example of round cells present in our eye and cylindrical cells present in our thigh. Both are doing different functions, as all of us are experiencing every day, isn't it? So, structure and function go together. That is what I mean. So, continuing with that, we are going ahead with second type of epithelial tissue. We said based on the structure, function, location, animal tissues are of 4 types: epithelial tissue, connective tissue, muscular tissue, nervous tissue. And as part of it, yesterday we studied epithelial tissue. In that, simple epithelial tissue we studied, as you may recollect from your memory. Today in this class we are going to study second type of epithelial tissue, that is called compound epithelial tissue. As the name suggests, compound means it is not one layer, it is simple. Like in your English you say simple sentence, compound sentence. When you say compound sentence, there are so many commas, and finally after some words and some phrases you put a full stop, then you say compound sentence. Like that here, compound epithelial tissue is a tissue that has got multi-layered cells. As you are seeing in the diagram, so many layers of cells will be there, and they have very limited role in secretion and absorption. Why? Secretion and absorption are done. Already we said simple epithelial tissue. So what is their function? Basically protection. They protect the internal organs against chemical and mechanical stresses. What do you mean by chemical stress? See, through nutrition we eat so many things in the form of vegetables, fruits, cereals, food grains, isn't it? And I am sure all young boys like you will be drinking Coca-Cola, Pepsi, all that, isn't it? So invariably they contain chemicals, unwanted chemicals, that too. The chemicals that our body doesn't require at all, and some of them are lethal, poisonous, toxic. So this tissue basically tries its best to protect those chemical entry. Okay, you can guess how does it perform that function? Any guess? Yes, Naveen, Shivkumar, any guess? Pallavi? Yes, Pallavi?
Since it is semi-permeable.
Yes, very good. It is osmoregulation. Very good. It is basically through osmoregulation, being semi-permeable, it should allow materials that are useful to us. Materials that are dangerous to us, it will prevent. Just like in science school entrance, you have got your security guards, no? They allow only Naveen. They allow only Shivraj, not entire Raichur or Sindhanur boys. Isn't it? So there is a selection process that will be done by this compound epithelium. And then mechanical stress. What is that mechanical stress? Stress due to activities, like when you are running, you are stretching. Say, particularly when you are stretching your body through exercise, a lot of stress will be there on the muscle, on the internal organs. So this skin has to overcome that. So that is the basic function of compound epithelium. And where this tissue present? It's present basically on the surface of the skin, and it is present on the buccal cavity inside. It is present in the pharynx and inner lining of ducts and pancreatic ducts. Pancreas, there's a gland in the abdominal cavity. So in all these organs, this tissue is present. And what is the basic thing here? Protection. Okay. And then there's something called cell junctions. Okay. What are these cell junctions? They basically provide structural and functional links between adjacent cells, one cell to another cell. In what way? They are connecting with each other. That connection, link, is done by cell junctions. So depending upon their structure, their presence, location, they are of three types. Tight junction, as the name suggests, junctions will be tight, cells will be tight. Adhering junctions, adhering means attachment, and gap junctions, as the name suggests, there will be a lot of gaps in that. Now I am just expanding that. Just see this. Like in the muscle, all of you know there is a protein called actin in the muscle, actin protein. Now look at the tight junction, look at the adherent junction, and look at the gap junction. Any difference in the structure? Look at the gap junctions, a lot of gaps are there. In tight junction, the cells are very closely packed. In adherent junction, you can see the cells are getting joined with each other. Okay, particularly the actin filaments. So presence of these will make cell and cell connection as well as tissue to tissue connection. Now look at this. Again, look at the tight junctions, that blue color adhesive junction and pink color gap junction. See the gap that is present. Okay, this is how the junctions, cell junctions will help us. So helps to, yeah, desmosomes are structures that are present inside the cell. Basically, we'll talk about that in the chapter 8, cell and its organelles, next chapter, after 2 days. Okay, we'll talk about that structure, function, right. So it helps to cell junctions, it helps to stop substances from leaking across a tissue. Sometimes there will be leakage, internal leakage. Many times when we get injured, when a person gets injured in an accident or while making sports and games, externally nothing happens. Even when I ask the person, he will say, sir, nothing, I am all right. But after 10 days, we will come to know that there was leakage of blood, internal leakage, and the blood started clotting, and that will affect the kidney. So sometimes even blood clotting will be there in the brain, leading to death. Hence, any fall, any accident, we should not neglect. The moment it gives a signal of pain, it gives signal of vomitings, okay, it gives a signal of nausea, we should not neglect it. Okay, so mainly these junctions, cell junctions, will help in stopping that leakage. Internal leakage will not be there. It performs cementing to keep neighboring cells together. How cell to cell communication will be there? Like I am all speaking with you all, because I have a cell phone and you have got a cell phone, I have got a laptop, you have got a laptop. We are connecting with each other through an instrument, and of course without data, without internet, we can't. Similarly, one cell will communicate with another cell through this cell junction. If cell junctions are not to be there, there would have been communication gap between cell to cell. And imagine what would have happened to the tissue without this communication, proper communication. So third point is they facilitate the cells to communicate with each other. This is the gap junction. Since the gaps, that gaps will be helping for communication. And how does it happen? By connecting cytoplasm of adjacent cells, one cell to neighbor cell. They communicate with each other through cytoplasm. And what for? For rapid transfer of ions, small molecules and big molecules. What are ions? Any idea? You are all studying chemistry? Yeah, charged particles. Very good. Like Na plus, Cl minus. So negatively charged, positively charged particles are called ions. Small molecules, can you give an example? Small molecules.
Hydrogen.
Yes. Yes, hydrogen. And biologically speaking, amino acids. You know, we say monomer, and monomers join together and form polymer. One amino acid, second amino acid join together form a protein. That is a small molecule, because only two amino acids are there. Let us say n number of amino acids are there. A joins with B, B joins with C, C joins with D, D joins with E, then it's a big molecule. We say mega protein, big protein. So all this get transferred from one cell to another cell within the tissue and within the organ through cytoplasm. And who is helping this? This gap junction. That's why their presence in our body is very, very essential. So three functions they are doing. Tight junctions help to stop substances from leaking across a tissue. Thanks to that, it's doing very good function. Adhering junction performs cementing to keep neighboring cells together. Otherwise, tissues would have been broken and they would have formed back the cells. And third, gap junctions facilitate the cells to communicate with each other by connecting cytoplasm of adjacent cells. What for? For rapid transfer of ions, small molecules, big molecules. So these are the various functions of epithelial cell. Now we go to the second one, most important one, that is connective tissue. See, without this connective tissue, our life would have become miserable. So we must be grateful, thankful to this connective tissue. And particularly all of you who are very, very active in sports and games, without this connective tissue, you cannot play basketball, football, hockey, for that matter anything. Even simple walking we can't do, because in our leg there are so many connective tissues. And if they were to be absent, we wouldn't have got the structure that we have got today. So, thanks to that. And what do they do? Basically, as the name suggests, connect means linking. It links, it joins, it adheres and supports other tissues and organs. So, one organ is joined to another organ. Yesterday I said, bone to bone is joined by ligament. Similarly, muscle joins or attaches to bone through tendons. So imagine if tendons were not to be there, And I'm sure many of you must have undergone this feeling that sometimes there is a muscle tear when you are playing and testing your stamina excessively, isn't it? And it takes a lot of time to get that torn muscle back into action. And I'm sure, like me, some of you must have been unfortunate having lost the ligament while playing basketball in our school. So then we realize the importance of that. Oh, we need to take care of ourselves. What is that? Do not cause any damage to ligaments. Do not cause any damage to tendons. We need to be careful. So for that, what is the simple thing that we need to do? What all of you do in sainik school. Before actually you start playing, you must warm up. Don't directly come from your hostel, go and play basketball. That is wrong. That's why your coach, APTC coach, what he will tell you? Your hostel students, what do they tell you? Take 10 rounds around basketball court. Shoot. Have free shots at the basket, maybe 20 times from all the angles, 45-degree angle, 30-degree angle, zero angle also. I am sure, Naveen, you must be practicing.
Yes, sir, we practice.
So that is what you should do. When your body is hot, warm up, then there will be very, very few chances of damage. Hence, don't directly go and play any game. Warm up and play. Similarly, most important again, after the game is over, your basketball is over, your football is over, your hockey is over, don't rush back and take cold water bath. Again, it is dangerous. You have a lot of pain in your body. See, your muscles will have cramps. Why? You played for 40 minutes to 1 hour and vigorously you played. You tested your stamina. You ran back to your hostel and opened the cold water tap and took bath. I am sure at least some of you got this experience already. So being biology boys, don't do that. You need to give, yes. Yes, Raghavendra.
Then there are chances of clotting, sir, directly if you go and
Yes. And that's why your body, see, fortunately, God has created our body in such a way that it gives signal. Before something drastic happens, it gives signal. So we have to catch the signal. That is what our nervous system should do. See, before you get fever, what does our body give signal to you? Body aches, muscle cramps, feeling cold, shivering. Then you get fever, isn't it? So you need to catch that signal. What is that my body is telling me? So that is why always we say, knowing thyself is better than knowing others. First you must know about yourself. We need to know about our body first, being bio boys, right? And if possible, it is our duty to enlighten others also. Tell senior citizens to go for a walk in your home, your grandpapa, grandmama, ask them to go for a walk, small walk. Do some light exercise. Tell your parents. This is what you need to transfer your knowledge to others. But then don't overstretch. There is limitation, no? There is Lakshman Rekha for everything. We should not cross that. Right. What is the basic thing that our connective tissue is doing? It links and supports other tissues and organs. Second, most abundant in complex animals. It is present everywhere in our body. All connective tissues except blood have fibroblast. So in connective tissue, it is made up of cells called fibroblast. You know, you must have heard a protein called fibrin in 10th class when you are studying blood. Did you?
sir, we heard in 9th class.
9th class only, very good. Can you tell me where it is present, this fibrin?
Sir,
Yes? Your nervous system is not helping you, memory. Isn't it? Activate your nervous system. Fibrin. You know blood clotting? Thrombin. Fibrin. Remember? So it's present in basically, it's basically present in blood. So fibroblasts will be there in a connective tissue, and what do? Look at that. They secrete fibrous proteins called collagen and elastin. As the name suggests, collagen and elastin, they help us to stretch. And if these two are not active or not present, what will happen? What you commonly say, school boys, muscle catch it is there, muscle catch it is there, isn't it? There's a muscle cramp, and it happens when you are playing particularly football, basketball, isn't it? Many times you experience that muscle catch. And what do? This collagen and elastin, these two proteins, they give strength to us, elasticity, stretchability, and flexibility. So if that flexibility is not there, the muscle becomes tight. And when muscle becomes tight, locomotion, movements will be difficult. And you will all of a sudden stop where you are. And you start shouting that there's muscle catch, I can't run, isn't it? And all those forwards in hockey, you must have got that experience. Because you need to chase the ball, that too running ball, isn't it? And you know that mentally you have to be faster than the running ball. So you pick up the speed. And if your collagen and elastin are not helping you, the ball goes out before you reach, isn't it? You missed a goal. So there is a lot of biology in the sports that you are playing. The cells also secrete modified polysaccharides. You know what is a saccharide? Basically, saccharide means sugar. Polysaccharide, many sugars are there. Okay? Like, glucose is a sugar, sucrose is a sugar, fructose is a sugar, isn't it? And when all these join together, that forms matrix, the central portion. And this accumulates between cells and fibers. Now let us see the diagram for this. Yeah, here is the diagram. Look at that. Yeah. See the collagen fibers, and see that brinjal type cells, fibroblasts, and see the elastin fiber. These three are very, very important in connective tissue. And this network of fibers actually give us strength for us, be it a muscle, be it any connective tissue, particularly ligament and tendons, and these provide strength and support for us. So in that, if you observe, look at the collagen fibers. They're very, very strong compared to elastin fibers, and fibroblasts are there, which are having proteins, isn't it? Collagen and fibrin. Now, based on the position, structure, function, connective tissue is of three types. What are those? Loose connective tissue, dense connective tissue, and specialized connective tissue. As the name suggests, loose connective tissue. It is connective tissue, but it is loosely arranged. So in that two are there, areolar tissue and adipose tissue. Second, dense connective tissue. As the name suggests, it is thick. Dense means thick. Dense regular and dense irregular. So cells are arranged in a regular way, in a particular way, then we say dense regular. If cells are not arranged in a particular way, irregular way, then we say dense irregular. And most important, my favorite, specialized connective tissues. These are very, very important for us. Look at that, cartilage, bone and blood. Imagine our life without this specialized connective tissue. No cartilage, no bones. Yes, Naveen? No bones means Can we be vertebrates?
No movement.
We would have become invertebrates. So maybe after echinodermata phylum, our phylum would have come. So thanks to this specialized connective tissue, because of this tissue, we are placed at the top. We have come to chordata, under chordata, vertebrata, under vertebrata, class mammals, mammalia. So we are at least telling that we are most evolved animals. So thanks to the tissue. Now, let us talk about the first one, loose connective tissue. In this cells, what cells? Fibroblasts, macrophages, mast cells. Is that? Mast cells. 3 types of cells will be there in this loose connective tissue. So fibroblasts, macrophages means big ones, they swallow macrophages, and mast cells. And fibers of course will be there. But why it is called loose connective tissue? All these are arranged in a loose way. We say semi-fluid matrix. So you can see the structure, areolar tissue and adipose tissue. See the gap, how much gap is there in between. And I am just making it in the next diagram. You see areolar tissue present beneath the skin. Where is it present? Below our skin. And it serves as a support framework for epithelium. So look at that, the loosely arranged cells. I am just making it bigger. Yes. And look at that. Macrophages, fibroblasts, collagen fibers and mast cells. See the gaps? That's why we say loosely arranged. Okay? That's how the areolar tissue will be present. And where is it present? It is present beneath the skin. When you see under microscope, we see like this, areolar tissue. And when you come back to Science school, you will see all this under microscope. Okay? Now, second one is adipose. It is mainly again beneath the skin, and the cells are called adipocytes. And what is the work? They store fat. So excess nutrients are converted into fats and stored in this tissue. So adipose tissue is mainly for fat storage. And what are the cells that are present in this? Adipocytes. Look at that. Fat storage area. So much of gap is there. Nucleus, plasma membrane. Right? Next, dense connective. We go to the second type, dense connective. As the name suggests, thick. Dense means thick. It is thickly arranged. So fibers and fibroblasts are compactly packed, closely packed. What about the loose connective tissue? Loosely arranged. So based on the arrangement, 2 types, dense regular, dense irregular. So let us see dense regular. It shows regular pattern of fibers. Look at that, regular pattern is there? Yes. See the pattern. See the collagen fibers, how they are arranged. Just like your NCC single file. Okay? And where are they present? Being dense and tight, they have to be present in most important part in our body, tendons and ligaments. So that's why it is dense, regular. And then you can see exactly, I was telling you the importance of tendons and ligaments. Tendons attach skeletal muscles to bones. Look at that. Bone to muscle. Yeah. I'm sure all of you, particularly those who are playing sports and games, you know the importance of this. Okay? And then, look at that. Most important thing, ligament. And particularly, though he is showing you in the foot region, okay, heel region, but you must take care really, all those who are playing sports games, your knee joint has got almost 12 ligaments, and look at the structure of the ligament, thick fiber. And I must give you a warning here. What is the warning? Ligaments are created by God, and if they are broken, we cannot replace it, because unfortunately ligament is the only organ structure that will not get blood supply. Okay, so when ligaments are broken, like me, you have to put on artificial one. Surgery is the only solution. So take care that ligaments will not get torn. And what is the best way? The best way is warm up and play, right? That is the only way. Look at that. I am sure Naveen will be doing lot of weight lifting exercise. Look at the biceps. They are like our Mahesh biceps. And look at the tendon. It is attaching muscle with the bone. Okay. Now, I think we are running short of time. Tomorrow we will connect the dense irregular. Okay. I think I will stop here. But before we go, irregular pattern of fibroblasts and fibers, this is called collagen. That is also present under the skin. And we will talk about that cartilage tomorrow. Okay, special connective tissue we will talk tomorrow, because this is really special for us. Cartilage, bone and ligaments, right? Until then, take care. I will be posting this PDF to you today. Go through it, draw the diagrams wherever necessary, label it, and after labeling, I gave a clue to you. When you are labeling, arrow mark should be towards the part, and being Fauji's, try to label on one side of the diagram. Don't put Indian Air Force type, right? And then understand the significance of each label. Like when you are writing, say blood, you are labeling it RBC. What is the significance of RBC? How many days it will be there? What is the lifespan of that? What is the shape of that? If RBC is removed from blood, what will happen? Like that. So try to understand the significance of each label, then you will become perfect. Right? For today's session, I am closing it now. Take care. Bye.